So welcome everyone. Thanks for joining us this afternoon. Apologies for the technical issues on my end. We will start shortly with the webinar. Before I do, I'd like to mention we'll be recording the session and you will all receive a copy of the recording tomorrow by email. And the recording will also be made available on the SimaPro Help Center, which is supported at simapro.com in a couple of days. So feel free to send your questions throughout the session via the chat box or the question box, and we will either address them immediately or wait for the Q&A at the end. So we're delighted to have the developers of AGRIBALYSE speaking in this session. It's a delightful panel. So thank you, Vincent, Robin, Anna-Claire, Helen, Laura, Audrey, and everybody who was involved in the making of this database. So thank you all for joining. Perhaps you can all tell a little bit more about yourselves and your role, what your role was in this project.
Good afternoon, everyone. I'm Vincent Colombe. I'm working in the French Environmental Agency, and I'm coordinating the AGRIBALYSE program and database for last 7 years. So I will introduce you a bit more about our work after. I think we can go by the pictures. Rolin, can you?
Yeah. Hello, my name is Roline. I work at Blanc Consultants since 2009, and for this project for AGRIBALYSE, we've been working on the technical side. So we've been developing the structure and combining all the data together into one database.
Yes, good afternoon, everyone. I'm Anna Slin. I'm from SIARI, and I've been on the French side coordinating the functional aspects of the database together with Ginkgo 21.
Good afternoon, everyone. My name is Hélène Telon. I'm heading the agency Ginkgo 21, doing life cycle assessment and eco design. And we've been working on this project for 2 years, along with Sayari and Rolin. And the team included Jean-Sian Gastaldi and Valentin Rousseau, and also Julie Houssier with Ginkgo 21.
Hello everyone, I'm Laure Nitschelm. I'm a postdoctorate at INRAE, and for this database I mainly work on generating new data for organic farming.
Hello everyone, I'm Audrey Rainbow. I'm working in ADEME, the French Environmental Agency. I am helping Vincent for the launching of this new database, AGRIBALYSE 3.0.
And finally, I'm Rupa. We probably have met virtually before. I'm the Senior Customer Services Specialist at Prey, and I help our customers get the most of our SimaPro family of tools. And I've been there for over 7 years. So I'll be facilitating this session amongst Vincent, Audrey, and the rest. So thank you all. Great that you could join us. Before I switch over to Vincent, I would just like to perhaps go through again where you can find the AGRIBALYSE database. So we released it last month to SimaPro users. We're very happy about that. And in the email we sent out to users, we sent a direct link where you can find the database. So if you go to simapro.com, and you can find the list of databases you can download. But before that, you have to fill in a form, and you have to make sure to agree to the terms and conditions. And at the moment, SimaPro, you have to have at least SimaPro 9.0 to be able to use the database. So like AGRIBALYSE, there are a number of databases that are not readily included in SimaPro. So when you first install SimaPro, there are in the library section, you'll find, for example, eConvent or AgriFootprint or other databases. But we also have a host of other additional data libraries available that you can download on demand. Some of them are free, like AGRIBALYSE for SimaPro users, and some of them come at an additional cost, but I advise you to check it out. So, excuse me. So from SimaPro, if you go to the help and then additional data libraries, it will take you to a web page where all the different data libraries we provide are listed, and there you can take a closer look. So. Okay, I think that's it for me. I didn't want to say much about SimaPro or Pray because most of you are already SimaPro users. And now I'll move on to Vincent for the more exciting part of their presentation.
Thank you, Ruba, and thank you for organizing the webinar. We're very glad to be with you today and to explain about this new release of AGRIBALYSE, which has been keeping us busy for last 2-3 years. So it's a big piece of work, and we're very glad we can share it with you. I hope you see my screen well, and so here is it's working. Yeah. Here is the team. So as we mentioned, here we only have a few people speaking, but behind that, it's been a huge quantity of work and a lot of contribution from the consultant teams. And thanks to everyone who's been very professional in developing that. So we'll go through the presentation with a short context, why we are developing this work in France, what our global aim with developing such a database. Then we have a quick look about what's new for people who already worked with AGRIBALYSE 1.3. So what's the difference about the new version? Then I will give the phone to the consultant teams who will explain you about all the methodology challenges that they have been through and how they answered them. We'll discuss a little bit about how can you use AGRIBALYSE in another context, because I guess most of you are not in France. And finally, how we see the future and what we plan to do to go on with the program. So just to start and know a little bit who we are talking to, we have just 2 questions to see where you're listening and from what kind of position. So I let Ruba do the poll.
Yeah, so I just launched the poll. Please, would be great if you can vote where you're attending from, France or another country in Europe, North or South America, Asia or Africa. We already have around 70% of the votes are in, so we'll wait a few more seconds.
That will help us to drive the discussion as well. So it was important for us to know a little bit about who is listening.
Okay, so I think now we can see the results. I don't know if you see it, Vincent, as well. 60% are from Europe other than France. So that's the majority of the audience for this afternoon. 20% are from France, 10% from the Americas, 10% from Asia, and 1% from Africa.
Okay, so mainly European country. And I think there was another poll about the position in your company and or if you're a researcher or so on. So also,
yes,
I'd like you
so maybe I can read. Yeah. So the second poll is also open. What is the role in your What is your role in your organization? Are you an expert, an LCA expert, an environmental consultant, researcher, policymaker, tool or IT developer? People are getting used to it. The votes are coming in faster this time, so that's nice. Okay, so quite interesting results. 51% are researchers.
Okay, big researcher community.
Yeah.
Interesting.
32
and I think
and consultants.
Are we 84%? I think we can say it's good enough. And the last one was to know about who already knows something about AGRIBALYSE.
Oh, yes. That's quite important. Let's see.
I don't know if I should hope that the yes or the no wins. Well, the no is definitely winning. So that's good.
Yes, but I think after
Many people will
after this
discover
webinar,
it.
yeah, exactly.
Exciting, very good.
All right,
Okay.
I'll close and share
Thank
the
you.
results.
And
Yeah, so it's a 70-30 split. Yeah. Okay, I'll show
very
you
well.
your, yeah, you should be able to go back to your slides. Yeah.
Okay, so the introduction is useful. So AGRIBALYSE is like a research and operational program that was launched in 2009 on a political agenda to promote sustainable production and eco-design in the food sector, and also to promote eco-labeling and environmental communication. And at that time, it was agreed that there was a big lack of a LCA database that would be reliable and comparable for agricultural products in France. We knew that some other countries were more advanced, and we needed to catch up. So we've been launching this AGRIBALYSE program in ADEM and with our partners at that time, with the first release of the database in 2013, with mainly data that were representing average farming practices. Then we had version 1.2, 1.3 with new data, always at farm scale, and some eco-design also system. And now in 2020, we jump from version 1.3 directly to version 3.0. So it's a big jump, but it's also a big jump in the scope of our work. And also that was to align for the different phase and like put all the numbers together. But I think it's reflecting quite well this huge quantity of new work, new data we put in. And also we have been refreshing all our communication and visual identity with a new logo and a new organization to manage the database. And so we will go now with data from cradle to fork. It's really important for us that you see it's a really collaborative program with many people involved. It's been step by step all along those more than 10 years now, with co-leading the ADEM, French Environmental Agency, and INRAE, which is the Agronomic Research Institute in France. So we, the two institutes, have been driving the program, and there's been, along with many different kind of project contribution from the technical institute, from experts, from consultants, from also agronomic schools, some international projects. And for this latest version 3.0, it was a consultant team that was in charge of developing this new version. So in total, we evaluate that about more than 100 people have contributed at some point to this work we're presenting to you now. Also, we're really glad to be a part of a more global LCA dynamic on food products. And we think it's really important, and we're fully supporting all the international efforts to coordinate the data, so on data interoperability. So we had GLAD presentation last month. We shared the AGRIBALYSE data in this GLAD network, and we think it's really useful. Also, all the work about methodology harmonization with the PEF and LEAP programs that are very structuring and that we're using, and all the other databases, because we also relied on other databases, especially for all imported food. So it's really important that everyone can contribute, and France will not make the LCA for all food products everywhere on the planet. So we need to collaborate in a clever way. So that's for the very big picture. Now, if you were used to AGRIBALYSE 1.3, you remember there was quite many agricultural data. If you were happy about it, you will be even happier about this one because we have included a lot more new systems. So we continue, as we were saying, at like the first release was really like only average farming practices, but now we have been going on with more specific and more like improved system, let's say. And so as you see, we have been including a lot of new organic production system with different characteristics and archetypes. So we have also been working, for example, here on Apple, you find so the conventional apple orchard, but you also find scab tolerant and a different pesticide protection, rain cover, and so on. So you can dig in the database and find lots of archetypes and varieties that might correspond to your system, and you can also see the benefits compared to a standard system. So that's what is really important, we think, and interesting. So until now, we had this AGRIBALYSE 1 and to 1.3. We even made a 1.4, but it's a kind of ghost version that it was only the agricultural part. We did not release it. We decided to include directly in the 3.0, and which includes the consumption mix. So that means the imports, all the processing, packaging, food, all the retailer, and at the end, also the food at consumer. And here we are. So that was the specifications that were given to the consultant teams. So it's really important that you understand the state of mind that we gave them to develop this new version. Then you understand why the methodology was built like that and how you can do what you can do about the potential of the work. So the scope was very clear from the beginning. The idea was to align with the nutritional database, French nutritional database that is called SQL. It's really the benchmark database that is used in France with all the characteristics for food products. It's about 2,800 products, so with a granulometry that is already quite high, but it's still average product. It's not at a brand level. So the request was to build a transparent and a well-structured database that would be allowing evolution and improvement in time. So the idea was not to make directly the perfect database, but it was more to work on the structure. And the idea was not at that point to go collect more primary data or look into very specific things, but really to build on the existing LCIs, because we knew there was already plenty of them. There was all the previous work of AGRIBALYSE. The ACIVIA was also a French program about focusing on food processing, and also to work with the other databases, and in particular, World Food Database and EcoInvent, that we could call like cousin databases. Which are quite homogeneous regarding the scope and methodology. We will come back on this in the methodology part. Also, the idea was really to focus on the hotspots in particular. So we know agriculture is most of the time a hotspot in the food products. So that was also why we had put our effort first in this sector until now. Look at the import with the consumption mix. And look also a bit more in detail for some we call flagship products that we know they would raise attention from the media or from the consumer. And for instance, for tomato, which is a very largely consumed fruit in France, we made a difference between the fresh tomato and the industry, like for tomato sauce, because we know the agricultural system is quite different in these two kind of products. So we made the difference at that level. But this is only for a limited number of flagship products. For the rest, we were more in a simplified approach. Also, we thought it was relevant to focus on where less data is available for the users. So to illustrate, like for food companies, it's really easy to know which kind of packaging they are using, which material, what is weight. And for us, it was very hard to define very accurately what is the average packaging of yogurt in the French market. So that's why we say we go for a simplified approach, and then it's easy for the user to put the specific data there. Whereas on the opposite, like finding the details on the farming, the dairy farm for a food manufacturer is not so obvious. And so that was important to provide and make more effort to describe well the farming practices compared to the packaging ones. We wanted to really have the full scope, so from, as we say, from farm to fork, but also we, of course, need to simplify. So the logistics, the processing operation, we went for a simplified approach. Considering the very broad scope and number of products, it was also important to have a deep review process. So that's what we did with the RIVM, which is a Dutch environmental and health agency. We made a review on the first version of the data. And Grid Delta reviews the method and all the DQRs, the data quality ratios that we implemented, and we had a final review by Core Consulting, which is a LCI expert, and also contribute to the big quality of the data. The reviewer conclusion were consistent. While they told us that they found the work was really innovative and useful to work on food system sustainability, that our results are consistent with the existing data and research publications. So they are not like a big news, breaking news, which is reassuring in a way. The database is really suitable for hotspot analysis, which means also that it's not very accurate if you want to compare very similar products, like an orange and a pineapple. Not pineapple, grapefruit. Orange and grapefruit are very similar. We use proxy. So if you really want to compare them, they might get the same value, the same LCIA, because we use the same proxy. So it's not really meaningful. So that's why you really need to take into account the data quality ratio. We spent good efforts to provide you with those quality indicators, and that really helps you on how to use the data properly. We also already identified some improvement options for the database, so that's we have things to work on. And also one point that was highlighted, it was like, if we really want to properly compare agricultural system, the LCA as implemented in AGRIBALYSE is not complete enough. So for example, some biodiversity, on pesticide impacts are not captured well enough to have a really complete assessment and comparison of conventional and organic practices, for example. So you need to go beyond our scope, and we need some more research to have a very complete assessments. The kind of results that you will be able to provide in a quite easy way. So for example, you will be able, for all the products, or the 2,500 products, to know very quickly which stage is the most contributing. So this is example for several cheese, and you see from the beginning that the milk is a more important part of the cheese impact, so the agricultural part compared to the transport, the processing, and so on. So if you want to go in an eco-design approach, you need to focus on your milk production as a first step. Also, you can see by ingredients when you have dishes with different ingredients. So here is an example, for example, for aioli sauce. And there you see that it's really olive oil that is contributing mainly. So if you want to make a more sustainable aioli sauce, you should start working on the olive oil inputs of your product. So this is available for all the products, basically. And that's the last slide for introduction. So as I mentioned, we try to harmonize with the SQL nutritional database of France. So you see like all the food categories that are covered. It's really covering all the food that is commonly consumed in France. In the nutritional database, there are 2,800 products about, and we could make only 2,500. So that means there are 310 products that we could not provide modeling for them. And those are very specific products that are not consumed in a big quantity, and then where we had no data at all. So for example, if you're very fond of lobster, we don't have lobster in AGRIBALYSE. Well, people usually they eat once a year at Christmas, and not everyone, so we can live with that for now. But we have some products like this that we could not model in a good enough way to make it meaningful. So we left them aside. So here I give the speech to the consultant team who will explain you about the methodology.
Vincent, just we have one question you can answer now, I think. This is why EF2 means in the slide with the results. The results are explained in EF2.
Yeah, indeed, we, okay. Oh,
Just before.
Yeah, I have a bit screen that are mixing a bit. I guess that's this one.
The one before, yeah.
So well, that's only for the example. In SimaPro, you can use the characterization method you want, but it's true that we have been working with the EF characterization method to build the flows to control that our flow and our nomenclature is correct, and it's also the results and the methods we recommend for characterization is the European footprint method, EF2, and now there will be EF3 that will be ready soon, but it should not be a big change for our data. Am I answering to the question? Yeah. Is there other things that we? No. Okay, we're good. Then let's go on with the methodology.
Okay, so we'll now have a look at the database in terms of how it was built from a methodological point of view. So here is an example of the data sets that we use for modeling the pizza. So you see in the end here, we have the pizza ready to be eaten. And we relied on existing LCA databases. First of all, AGRIBALYSE for the agricultural part here on the left. Then we used different databases for transformation of food items, either Acivia or EcoInvent or World Food Database. And we also relied on EcoInvent and PEF data for the downstream processes. And we had to create original processes, which are here in green, modeling both recipes and consumption mixes of raw materials. And for that, we relied on existing databases, but not life cycle assessment databases. So we'll see that a little bit later. These were the missing link we had to build. So we can move to next slide. Okay, next slide. Okay, so here is the architecture in SimaPro. So you see the different stages that were already mentioned by Vincent, from agriculture to transformation, packaging, distribution, retail, and final product. So you see in red how they are named, and you find this information here. So it might be a little small on your screen, but in the name of the process, at the end, you see at what stage is the product. So it could be at distribution, at consumer, and so on. And The structure is made according to the Ruschen-Dohls principle, which means that the downstream processes include all the upstream processes. And last information, which is quite interesting, is that in the name of the final product, you see the SQL code, which is the link between the AGRIBALYSE 3.0 database and the ANSES nutritional database. Okay. So now we can move to next slide. And we have two types of information here, one on recipes and the other one on consumption mixes. So these are both missing links that I mentioned earlier. We have used 3 different sources for recipes. We have about 50 recipes coming from retailer in France. We also got more than 500 recipes from ANSES, and we also found some recipes in existing LCA datasets. There's one proxy which is important to mention, is that the recipes which were provided by ANSES are homemade recipes. So we made the assumption that they are similar to industrial ones, which is of course not true. So this is a proxy, and we have to be aware of this limitation. And last point on recipes, there are many ingredients in some recipes, so we decided that we set up a cutoff rule of 95% in mass, which is quite precise. Now, regarding consumption mixes, when you consume tomatoes in France, of course, they are not all grown in France. So we had to dig into FAO statistics to find out what was the mix of the origin of the vegetables and fruits and so on consumed in France. We decided that we should do that in an average over a 5-year period. And here again, we set up a cutoff rule of 70% to identify the major countries of origin of food products. Yeah, the consumption mixes only apply to raw materials, so we didn't consider that France imports also processed food. And as Vincent already mentioned, there's no organic mix or mix for sustainable practices. This will come probably later on in future version of the database. And there were some investigation on a very limited number of products. We conducted in-depth study to check the difference in consumption mixes on 2 characteristics. The first one is the food going to be eaten as such, or will it be processed? We did this investigation on 4 products, which were tomatoes, strawberries, chicken and beef. And we also investigated the difference between the mixes for on-season and off-season for tomatoes and strawberries. So now I hand the
Helen,
slides
sorry,
to Anne-Claire.
Can I ask you a question, please, Helen, from the audience?
Sure.
If you can elaborate, please, on what you mean by consumption mixes.
Okay, sure. So when you consume tomatoes in France, the first thing we could have done would have been to look into the existing AGRIBALYSE data sets for tomatoes. But these are tomatoes grown in France, whereas what is consumed in France is might come from Spain or Morocco. So we modeled at least the transportation from Spain and Morocco, and ideally we would like to have a specific data set for growing tomatoes in Spain and Morocco. Is that clear?
Yes, I think so. Thank you.
Okay, thanks. And Claire, you want to keep talking?
Yes. Hello,
Sure.
everyone. I guess can you hear me well?
Yeah.
Okay. So the next slide is about processing and packaging. So for the processing, we have 3 points that are important to have in mind. So processing is actually the transformation of a single raw material into an ingredient, like, for example, transforming wheat into flour. So the assumption for all those processing is that it happens in France. A second point to have in mind is that for a few of them, which are listed here, they are dummies, unshelling, peeling, pitting. Those are dummies, and we assume that they don't have a very significant environmental impact. And third point, for some products, we had to use a default process. Despite Helen pointing out we didn't work on processes too much, we still had two missing processes that we had to elaborate on. And for example, for plant-based drinks, we only had one process that exists in EcoInvent for soybean drink. And we used, for all plant-based drinks, we used this one, but we replaced the raw material. Almond drink was the soybean drink dataset, but replacing soybean by almond. Other cases is, for example, milling. We had the milling for wheat, and we used it for barley or an oat. We also had two data sets for cheese, hard and soft, to actually model the 50+ cheeses we French people love to eat. So for that, we also had to use this default process approach. Coming on packaging on the right side, as Vincent already pointed out, we have rough assumptions for packaging. The assumption is we actually made, helped with the SQL categories and aligned with them, 13 categories, for which we thought that packaging was dealt with kind of similarly. So you have two examples here. For raw fruits and vegetables, we assumed to have no packaging, and this for all of them. For alcoholic beverages, we assumed to have glass packaging, and for all of them. So this is quite archetypical. This is quite simplified, but this was one of the choices that we made. Also, we only considered the primary packaging, and in some cases, primary packaging is not one single material. We can think of a box of cereals, for example, in which you have a cardboard box and you have a plastic bag inside. So in that specific case, for example, we just looked at the heavier packaging, so the cardboard in the case of cereal box, and not the plastic bag, and not the lighter ones. Packaging modeling is based on the mass ratio. So we look basically at the mass between the packaging mass and the ratio of the ingredient mass. And we use, this doesn't appear on the screen, but we use data from FoodJess. Next slide. Here, and this is kind of very small, I'm sorry about that. You have a screenshot of a process, and this is cheese. So obviously, it's when you look at the title of the data set, the PGI little ending of the name means that it comes from Acivia. But in the metadata of the AGRIBALYSE created data sets, anytime you will have the information where the data set comes from, which database, then you have the co-products of cheese that are here, whey, cream, etc. The economic allocations are parameterized on the right. And then in the Acivia dataset, you have also the inputs with the raw material, which is here. One of them, one of the very important ones, obviously, is the cow milk, which is here. And they are also parameterized. Now, if we step back a little bit, and if we go with the cross-cutting vision on this database, there are two ratios that really matter because they actually are ratios that change mass across the value chain. The two ratios are quoted here. it's number one, the raw to cook ratio on the left, and number two, the ratio on inedible losses. If we dig a little bit more into the raw to cook ratio, so it's actually a ratio between the weight of food items when cooked over the weight of the same food item when raw. So for pasta, for example, you would have, of course, cooked pasta is weight much more than not cooked pasta. So raw to cook is higher than 100%, whereas for bread and meat, you have a raw to cook that is lower than 100%. So the change of mass has to be accounted for within the database and at the right stage. In order to compute this ratio, we use data from SQL. So we are very much aligned with the nutritional database again, and we use the water content data of SQL. On the right side, you have information on the inedible losses. So first point to have really in mind is that this database is a farm to fork database and not a farm to mouth database. So we don't account for avoidable losses between the plate and the mouth, but we only account for inedible losses. So for examples, you have some here: bones, pits, peels, shells, etc. And the stage at which the inedible losses is accounted for matters quite a lot, or can matter a lot, because it can significantly change the mass that is transferred to downstream stages. For tomatoes, it's only 3%, the inedible loss, it's the peel. But for mussels, the shell represents 75% of the overall mass. So you really have to, we had to be aware where to account for these inedible losses. And for this data here, we use again the FoodGES data. The two ratios, raw to cook and inedible losses, are not necessarily used at the same life cycle stage. And you have an example here for cooked rice. So the raw to cook is accounted for at consumer, whereas the inedible losses to transform the rice at farm gate into rice ready to be consumed at plant gate is accounted for at plant. I hand it over now back to Hélène.
Okay, so next slide. Okay, this is just this was for you too, and Claire, just an example of inedible losses. You want to add?
Yes, I thought just an example of inedible losses. Again, in the example of that we follow, the thread that we follow on pizza. And for your tomato in pizza, you actually need to account for tomatoes, but you need to account for peeled tomatoes. And those tomatoes for processing, peeled that you account for, they actually have as an input tomato consumption mix, but 1.03 as an input, accounting for the inedible losses, the 3%, and the losses are dealt with as bio-waste. Again, you can see here in the table below that depending on the different fruits and vegetables or product ingredients, you can have very different inedible ratios, inedible losses ratios. For lemon, for example, it's 40%. So it can vary quite a lot.
Mm-hmm. So now we go downstream. We want to give you insights for each step of the life cycle and how they were dealt with from a methodological point of view. So now we turn to distribution and retail. So the main impact for distribution and retail are energy consumption, in particular for storage. And for this point, we defined it classes of product. So according to storage conditions, you have ambient storage or cold storage or frozen storage. And for this, we mainly rely on PEF data. which is a good way to be consistent with what is done at the European level. Another important source of impact for distribution and retail are food losses. So here again, we modeled them and we are consistent with the PEF data. And the last source of impact is, of course, transportation. So we defined some average distances of distribution and from the distribution platform to the supermarket, 150 kilometers. So these are average data. And we, of course, the user will be able to change and to customize these transportation distances. One point of importance is that ADEME in the tender asked that the transportation from the supermarket to the consumer should not be taken into account. So we didn't model this step. And we can move to the next slide, which details the transportation all along the life cycle. So we just said that this transportation to the final consumer is not modeled. And we have not modeled transportation between processing and assembly for a recipe. For instance, we make the assumption that everything happens on the same plant in the same site. And regarding the the upstream transportation, thank you. For instance, if the raw material is produced in Brazil, then we'll have some transportation for bringing oranges, for instance, from the growing area to a hub, concentrating hub, and then we'll have a transportation modeled from this hub to France. Okay, so this is how we modeled. There's no next slide here, it's hidden. So I just explained right now what's coming. And then the last step is about preparation at consumer. So here again, we have impacts linked to storage and preparation. Regarding preparation, we modeled different types of preparation that you can see here, either going from no preparation to oven cooking and so on. What is important to note is that we assume that for recipes, everything is done at the plant, and the consumer just has to reheat the meal. And regarding storage, we have a very logical model according to the storage type, either fridge, freezer, or just ambient. Now, Rolene.
Yeah, thank you. So the whole database has been rated in terms of data quality, which is very helpful for you to get an idea about the quality of the data and whether you want to use it or not. So this is an example for data quality for pizza, which has been rated at 2.79. You can find this rating in the process in the tab documentation in the comment line. So the inspiration for the data quality ratio is the PEF methodology. We have used 4 data quality indicators, which are precision, time representativeness, the geographical representativeness, and technological representativeness. And the 4 DQIs, they are evaluated for the most relevant life cycle stages. So a score of 1 means that it's a good quality, and a score of 5 means that the quality is quite low. Next slide, please. So There are 6 main life cycle stages which are identified. They are in this slide in blue. So we have the market mix, the processing, the recipes, packaging material, distribution and retail, and the preparation. These are the 6 main life cycle stages. And for each of these life cycle stages, the 4 data quality indicators are attributed, considering specific characteristics. There are some additional parameters at various stages of the life cycle, which are considered separately in the DQR rating. These are in green. They are the allocation fractions and the mass changes. So the changes of mass fractions in each of the processes. And in orange, the transport. And there are also 3 parameters for which when there's a proxy used, it impacts data quality, and they can result in a penalty. So then the DQR rating is worse when in the case that there's a use of a proxy. Finally, when all these different parameters are rated, the DQRs are multiplied by the weighting factors of the contribution of each life cycle stage to the final impact. And this helps to calculate the overall 4 data quality indicators. And the average of these 4 indicators gives the single DQR value. Next slide. Here you see an overview of the distribution according to the DQR per food category. So you can see that the data quality is quite different between the food categories. For instance, for processed meals and milk and dairy products and cereals, and the data quality is quite good, while for ice creams, there's still some room for improvement. I hand it over to my colleagues.
This is the last slide of this presentation on methodology. And again, let's come back to the example of pizza with limitations and possible updates. As you are juggling with the database in SimaPro, there are unlimited possibilities of playing with the data sets that are in AGRIBALYSE. So you can actually overcome the limitations, and here are a few examples of how you can do it. So if the first limitation can be that the recipe does not necessarily correspond to your recipe, and in that case you have to go to the data set at plant, so at plant gate, and to update the quantities of the different ingredients, add or remove the ones that are not within your recipes or that are in your recipes. Difficulty is, well, fairly important. You just have to make sure that the ingredients masses are accounted for before cooking, and the impacts can actually be significant or even major depending on the changes that you make. Second limitation is that we deal with mozzarella as a generic soft cheese production as a proxy. So if you really want to have a real mozzarella cheese in your pizza, you have to create a new data set for mozzarella production and replace this data, the cheese, the average soft cheese, with this new mozzarella data set. And obviously you have to have specific knowledge from industry to do so. But we assume that changes can be significant, especially on milk yield. third limitation can be that the peeling process for tomato, for example, is a dummy. Then you would have to replace the dummy with the actual peeling process. Again, you need data from the industry to do so. And the impacts would probably not be that important. We expect low energy consumption in comparison with other processes such as drying. And last example, it's of course just a few examples. You will encounter many more than that we could look at. But if you would want to account for the transportation from supermarket to consumer, you would have to add the transport input in the data set consumer and get information on the distance as well as the basket allocation of the specific food. But the impact can again be significant depending on the new assumptions that you take. And that's all for the team, for the consulting team.
Thank you, Anne. Can I just ask you a question? When you mentioned you've used a dummy process, is it kind of a placeholder? So it's has empty fields, but it can be used to be adapted by the user.
Exactly. It exists. The name is explicit. So at the end of the name, you have dummy process so that you're not mistaken and that you can quickly identify that this process is empty. But at the same time, it exists and you can definitely replace it with a no dummy process that you would have created with your own data.
Okay, thank you.
There are several questions about losses, I guess for Anne-Claire or Hélène. One about inedible losses. Does it mean that the emission factors apply only on the product less than the losses?
I'm not sure I understood the question, Audrey. Can you please repeat?
I'm not sure as well. The question is about the inedible losses. And the person asked if does that mean the emission factors apply only on the product and not on the losses, I guess.
Well, I understand this question as being, does it mean that we account for the losses within the impacts of the products? And actually, when you have, for example, let's take an example. If you have a pork chop and there is bone, then the bone is obviously not eaten by the consumer, but the emissions and the impacts will account for the overall pork chop, including the bone. So actually, we would also account for the impacts of what is actually thrown away because it's inedible. I hope this makes it clearer.
Well, I suggest where either the person can rephrase his question, and also we have the methodological report, which is explaining in details everything. So maybe you can look at it in a more peacefully and come back to us if there are still some questions.
There has been another one about losses, but I guess it has been answered through the presentation because the question has been questioned a long time ago. We have a question about water consumption at distribution and retail because you did not mention that in the slides. So the question is why? What about the water consumption at distribution and retail? Is it not significant?
Well, I just mentioned it's a very quick presentation. So I mentioned the highest sources of impact, which are transportation losses and energy, but of course we take into account other impacts if we have some data. So if they are modeled in the PEF, we take them into account too. It's just because it's a short presentation, and here again I can refer you to the methodological guide, which is public.
Another question about waste. Does the disposal of the food waste life cycle stages has not been included? I'm not sure to understand.
Which type of waste are you talking about?
It's not clear for me.
Okay,
Food waste
so
life
we have
cycle stage. I
all the
think
losses. Oh, sorry. Well,
I think
all the losses. Oh, okay, go ahead. Sorry.
Yeah. Again, we said that the database is from farm to fork. So the losses that happen between fork and mouth are not accounted for. So, and for the rest, if there are losses along the value chain, for example, at distribution, retail, or at processing, they are accounted for, and depending on the products, they are different, obviously, but they are accounted for. But not the food losses at consumer that could be avoided.
Thank you.
Okay.
We have a question about difference between AGRIBALYSE and EcoInvent at the plant level. Can AGRIBALYSE and EcoInvent be combined? And what are the main differences at the plant level?
Maybe I take this one as there are very little differences in our point of view. We did not go for a very, very detailed analysis. The thing is that while EcoInvent doesn't have many agricultural products, it's mainly World Food Database data that has been, for some of them, included in EcoInvent. And there might be some small modeling differences, but it's also to take into account the region of production. So in France, there's been a big work from the Technical Institute about the enteric emissions, so the modeling of cow emissions, and so we have more accurate modeling than the standard EcoInvent data. But so that kind of small differences. Sometimes we have more accurate, emission emission modeling, I would say, and for the rest, it's really similar.
We have a question about can we generalize this methodology for ASEAN countries?
I will come back on this on the next part of the presentation, so I will keep it for later, this one.
One question for you, Vincent, I think, or maybe no. How do we model the different cultivation techniques in terms of inputs, which are different according to the regions, about fertilizer, pesticides, and so on?
So here again, we did not model in this AGRIBALYSE 3.0. We used existing data sets. So the one from France, well, you should refer to the French methodology report, AGRIBALYSE 1.3. And well, we've updated it, but so it was the French modeling approach that was used. And then for the rest, if we use the world food data for banana, for example, then it's a world food modeling approach that we did not change anything.
A more general question about the quality of the data. Do we provide quantitative assessments of uncertainty in addition to the DQRs. I guess Vincent can answer that.
Well, the answer is fast. No, we already, it was quite a big effort to provide the DQR, so we don't have other indicators. Wow. I see there are quite many questions.
Yes, indeed. Maybe we can move on with the poll and then leave the rest to the Q&A at the end.
Yeah, I suggest we do that because it's I think it's good way. We move on with some answers will be provided directly in the rest of the presentation.
Yeah.
Okay.
Okay, so now you have a good insight about the work. We wanted to ask you a few questions about how you see that.
Yeah, so which part of AGRIBALYSE 3 is the most valuable to you? You can select one, which is the most important. I think we have a winner, but the votes are still coming in. Okay, so far it's around.
We were right to focus on agriculture from the beginning. It was not wrongly.
Okay, I'll close it for now and share the results. So indeed, it's around 66% voted for agriculture. And the least important of the audience view is inedible losses and raw to cook.
Okay.
Did you want to do the other poll as well?
Yeah, I think it's good. You can also.
Okay. So in this case, you can please choose 2 choices at most. And what do you think is key for a food database? Is it the transparency, having less proxies and more accurate data, completeness, improved LCI AI, or harmonization with other data?
This is very well balanced.
Yes.
Interesting. Well.
Okay, we'll wait a few more seconds. Please get your votes in. Unfortunately, we can't vote. Okay, I'll close it up and share.
Thank you. We also value a lot the transparency. We believe that sometimes it's better to have a transparent data than spend a lot of energy to have something very accurate, but sometimes less transparent. So I think we are in line on the approach. Okay, let's move on with the presentation. It's going to be quick, the last parts, but I think it's good to step back a bit also and share about more the global vision. So as I understood, many of you are not French, bad luck, sorry, but you're here, so you're interested in the database. And so well, we try to give you some advice on how to use it for the best. So if you're interested in the agricultural data sets, I think you really should pay attention to the climate and soil condition of your area. We know agriculture is very diverse considering the world region, and if at least you just check the yield and the, let's say, input intensity fertilizer, if they are quite similar to the one you have in the database, and it's fine. I think our data can be used without any problem, but if not, you should really pay attention and not use them directly. The consumption mix, it's important to adapt it. So I'm pretty sure that in the USA, you don't import tomato from Italy and Morocco. So the consumption mix is really suitable for France and should be adapted if you are in another region in the world. The process also, it's mainly energy, but it's a French electricity mix that has been used, and also heat mix. So it's important that you adjust it with because France has a very nuclear electricity with very low CO2, and so that can be quite different in depending on the country. Also, the packaging, especially the end of life and waste management, is specific to each country. The recycling shares, well, all the waste management, so it's important to adjust it. Logistic can vary. For the transportation in Europe, we have the EU regulation about the truck efficiency, also the distance between the retailer, the producer, and so on. So this also needs to be adjusted if you're in very different contexts. The type of food that you will encounter in the database is really corresponding to Western living style. So if you're in Asia, for example, there are a lot of products that we don't eat in France, or very little, so you will not find them in the database. So don't be surprised. And finally, the data quality ratio, it's really adjusted to the French conditions. So we say how good is the data for the French conditions. So if you use it in other countries and so on, you really need to adjust it because it's meaningless to keep it similar. There will be further data analysis that are ongoing and that we will share with some publication and so on that will also help to have a better and more accurate view about the whole database and data sets. The key messages, and if we want to keep it simple, as we really believe that our data is good as a first approach proxy for European country, because you won't find major differences we expect in general. And so if you don't have national data, then you can use the French one. But if you are in a more different context, I think it has a lot of value or work because even if you cannot use directly the data, it's a really good framework modeling approach that you can adjust to reflect your condition. And instead of starting from zero as we did, you take our database and you adjust the points I mentioned before, depending on your context, and you can build your own national database in a very more efficient approach than starting from zero. So as I mentioned, for southern countries, I would really advise not to use AGRIBALYSE as such. We also want to raise that we need more data for import because we had to use quite many proxies. So sometimes we included the transportation, but we could not adjust the production condition. For example, for tomato from Morocco, we did not have a Morocco production LCI, so we use it. We use Spain as a proxy for Morocco. We just adjust the transport. It is not fully satisfactory, so it's really important that more initiative as AGRIBALYSE, and especially for the agricultural level, that we have some good data available. Also, we would be really happy to share about our experience to consider support and collaboration, and in particular in the framework of EU projects. So please, if you're interested, come and let's discuss about it. And well, hopefully we think it can be an inspiring project for other countries, and we hope that there will be more databases available in coming years. So we have a little breath poll transition 1. Ruba, I let you.
Yeah, so do you think that developing databases such as AGRIBALYSE at national level is very useful, kind of useful, or not so useful?
Please be frank. If there is no pressure, no pressure. It's anonymous.
It's anonymous indeed.
The question is, what is a good level? Does it make sense to make national databases, or we can work on more global and regional approach, and you think it would be sufficient? That's a bit the question.
Okay, I think we have a clear winner.
Okay,
so
thank
most
you.
of the audience, yeah, finds it extremely useful.
Okay.
So that's good to know.
And so I go to the final part about the follow-up and how we see the future work ahead. As I mentioned, we already identified several improvements, possible improvements, especially on soil carbon that we don't account at the moment. On pesticides, so there we already have some bullets. We have been working on a European project that is called Pest LCI to better include the pesticide use and impacts. So I think we can really improve in the short term the database. And there is still a huge topic about the biodiversity indicators that are not at the moment well represented for the food sector. We mentioned that for the recipes, we really have improvement possibilities, as a recipe at the moment are like at home, and we think it's mainly maybe more industrial recipes that are interesting, because at home people can adjust quite easily, they know the quantities and so on. So, or at least we could provide both to the two values, but we know it's very different. The industrial food companies, they don't use the same raw ingredient and so on. So it's an important point. We see also some gaps that are, I mentioned the lobster. If it would be only lobster, that I would be happy, but unfortunately there are more common products that are still missing. So for example, the mushroom, for salmon, we use proxy as truth, which are very common products, and there we really should improve the database. The industrial processes also deserve improvement. For the drying, we have only one processes that we apply for all kind of products, whereas we know there are different technologies and efficiencies, and so there is improvement to do there. And the last point is we think would be really added value to provide not only the standard conventional food at consumer, but also to provide the organic food. But it's not, well, we're at farm, we already have organic products, so we could just say we switch the conventional with the organic, but it's not so simple, because we know like the organic consumption means the import of organic product is not the same, the origin as the import of conventional products. The logistic is also different. So it's all about an adaptation of all the value chain that is required. But I think it's feasible, but it needs some effort. We also identify that for some product like cacao or coffee, there's a huge share of deforestation. So would be really interesting to provide a cacao with like a no deforestation label to show the difference with a conventional product. For some products, the packaging can weight significantly. For example, the coffee, when you have individual capsules, or if you have big batch of coffees, we know it has an important environmental relevance to differentiate this. But as we were focused on the nutritional typology, of course, from the nutrition point of view, it doesn't make any difference. So we will need to make a refinement in the classification if we want to go for this in the future. also, what is we want to share with you is really, well, we talked today a lot about the database. It's probably the most visible part of the work, but really AGRIBALYSE is a program. It goes much beyond that. So, well, we have the database. It has two formats. It has the full LCA database format that you have in SimaPro, but we also provide on our website a simple with table Excel format that will be available from September 29th. We also provide a lot of documentation, and we have developed a whole network of experts in France in each sector for the crop, from the vegetables, from the meat. So in every sector, we really have people that are skilled that can answer in detail about all the questions. And we also provide trainings, webinars. So the idea is really to get all the community to improve and learn, thanks to this program. And our data, they're not to be used only directly, but they're also meant to be used broadly in some more sectorial tools. So there are already some tools that are using them. So that's our French tool for livestock, for agricultural modeling. It's also, we want them to be used in eco-design scheme, in sustainable schemes, in all the private labels that are developing. So to make sure they provide like significant environmental benefits, and so to prove it with the LCA data and such as AGRIBALYSE. And also there's all the more the consumption part, and so there's a eco-labeling policy that is promoted right now in France with some testing by the companies that is going to start this year. Also work with catering and on the food diets, the evolution of food diets, and where AGRIBALYSE data are very useful. So we really want to see this work as a dynamic with a network, with the documentation, with the data, and progress every year. We improve, we evolve, and we develop new collaborations.
Great, Vincent. We had a question regarding accessibility. So so of course it's available in SimaPro, and you also mentioned it will be available for download in Excel in some sort of simplified format from your website. Is it also available in other tools like OpenLCA or Gabi?
It is available in OpenLCA, not in Gabi. We did not have the request from them so far, and it's always a format issue. But our wish is it's public data, so well, it's just we need to manage the technicalities about the format conversion, but it can be available for anyone. That's really a wish to make it.
Okay, thank you.
So as we say, we focus on the user focus approach with the documentation, the website. We try to make most of it all in French and English. There is a contact forum and contact form, so you can reach us if you have questions. And also we would like to evolve to a more contributive approach, because so far it's been all the data have been developed either internally or calling for other databases, but we think, like I said, we don't have honey data right now. We could not find in any database, and we did not develop ourselves. And we think that if we have users that have good quality honey data and that are ready to share them, we would be happy to include them, and so to also be in position more to review and make sure of the quality, and not to develop ourselves all the new data in the future. I think it would be a more efficient way to work. And we estimate that we should be able to provide an updated version by the 2021. So it's also the idea to keep the updates every 18 months, 2 years. That's our capacity right now. I get to the last slide. So as you understood, we really hope that we can provide a benchmark and innovative tool for the LCI community. We want it to be operational and to really bring LCI deeper in the discussion of the food, in the strategy of the companies, of the policies, really bring knowledge for the ecological transition that is needed. we want to keep on being user focused, provide something that is useful for you. But I think when we say user, we are very much restrictive because you are much more than users. You are all experts. You can be contributors. We need you also. You will use our data, you will review them, you will find some mistakes. There are always some mistakes when you see how many data we build, and so we really need your contribution to improve also. And even further than that, we would like you to be a bit our ambassadors. If you think the data is useful, the presentation was well done for you, talk about it to your colleagues, talk about it to your boss. We are really a small team, and so if we want the tool to be more known, we need the network to also share and talk about it. So it's really important that we all can support at the LCA in the LCA community. Thank you. That was my last slide, and we have a conclusion poll before the questions.
Yes, thank you, Vincent. I'll go for the last poll. Looking at the time, and so what would you, after listening to the webinar so far, what would you use AGRIBALYSE for? The majority of you were researchers and LCA experts. So in that sense, would you do it for your LCA studies? Use it for labeling, eco-design studies, policy development, or other applications? Okay, again, a clear winner here. Most of you did LCA studies. Great. Followed by some for environmental labeling and eco-design. Not for policy development yet. Not yet. Okay. Okay, so Vincent, would you want us to share some more questions, or is there anything else you want to share at the moment?
There is one question interesting, I think, about the link with the open platform on life cycle assessments. Question is, will AGRIBALYSE become an approved data node with the European platform on life cycle assessments?
AGRIBALYSE so far is not directly a node on the EF platform because it was only the EF, it was call for tender. So they asked for some food data for France. So we provide AGRIBALYSE, but it was a very limited data set that was asked by the EF program. And so the EF, at the moment, they don't want to call for data that are from different regions and so on. It's more, I think, the GLAD platform is more the platform where we will find all the data.
I think we have a question for Laure, specific about organic products. Have that been updated from the version 1.3? And is the land occupation now included in the 3.0?
I don't know, Audrey, if you can have a helmet or something. Your sound is really bad.
So I am sorry, I cannot be better now. Is it better? No.
I can maybe reread the question. So for the organic product datasets, have they been updated from version 1.3? And is land occupation now also included in version 3?
So yes, we have updated organic product, and now we have a set of more than 100 LCI for organic product in AGRIBALYSE database, and we have included land occupation in all of our LCIs.
Shall we do one more final question then? Okay. Is there, this is regarding the documentation. Why is there no documentation directly added on the datasets in SimaPro? I guess you're referring because I guess because in eConvent you can indeed access documentations from your data set. Maybe that's something we could look into, Vincent?
Well, we could bring the link to the report, but we don't have a documentation splitted by each data set. That's a huge work, and we don't intend to do it on the short term. So, well, we could make a link to the report in SimaPro. That's easy, but it doesn't make a big difference, I think.
All right, just looking at the time, I think that's it for this afternoon. I hope
maybe
for those
Ruba,
of you,
I just would be interested to share the poll number sent about the priority, because we are also in a time where we're thinking about where we should put our efforts in the future. So
yes,
I'm
I'll do
interested
that.
to have the view of the participants.
Yeah, so one more poll. Thank you so much for staying with us. So what would you think the focus for the ADEM team should be on improvements for AGRIBALYSE? Inclusion of more agricultural products or more diversity in terms of having more organic or local food products, having more accurate recipes, diverse food industry processes, or more accurate modeling for the main products. Okay, one more few seconds.
Okay, well, that's recipes is not seen as a key topic. Okay, that's interesting.
No, so that's good for you to know. Indeed, it's good we share this poll. So yeah, I think the top three are having more agricultural products and diversity of those food products and more accurate modeling. So now you know where to focus your efforts.
Quite well balanced. Thank you, Ruba.
Yes.
I let you conclude.
Yeah, sure. Thank you all for joining us. It's been quite a session, a lot of speakers, a lot of questions. Some of the questions have been unanswered. We can follow up by mail afterwards with the right consultant. We will share the recording, and it will also it will be sent by email to all of you, and I will also include a link where you can download the database from our